Okay, guys, welcome back. So this is covalent bonding. This is the second type of bonding of three that we're going to talk about. So just to recap, ionic bonding is between a metal and a nonmetal. Electrons are transferred and the atoms are attracted because of their opposite charges. So that's an ionic bond. It's formed with ions. Now we're going to talk about covalent bonding, and covalent bonding is sharing electrons, and sharing is caring. So for instance, I can't afford a boat, but I'd love to have a boat. If I said, hey, why don't we be co-owners of a boat? That would mean that we were going to share the boat. Okay. So covalent bonding is sharing electrons. So they both have what the other one needs and they kind of pool their resources together to get what they both want. And remember the octet rule, a giant 8. 8 is great. They all want 8 valence electrons, and that's what they're still trying to achieve, just like in ionic bonding. Okay, so like I said, what holds the atom together is the protons in the nucleus and then the electrons on the outside. Well, when they share, the protons of the nucleus of the other atom can be attracted to the electrons of the other atom, and they kind of hold themselves together. So it still has to deal with this opposite charge attraction, but they just share their electrons instead of transferring them. Slides. If you look, that hydrogen, this line, each line, when you see a covalent bond, represents 2 electrons. So, and that line just replaces those electrons that are being shared. And once again, tons of practice in class. Just to go over a few terms with you, this one is called a single bond. It is one pair of electrons. Okay, so it's actually 2 electrons, but we call it a single bond. This right here is 2 pair of electrons, so there's a total of 4 electrons in this one right here. Okay, and then in this one, this is a triple bond. This is a total of 3 pair of electrons, which is a total of 6 electrons. Okay, we're going to go over in class how to draw these, how to see these, but it's like a puzzle and it's kind of cool. Just another example, you can see these, and you don't need to know all of these, but you will see them drawn multiple different ways. But I just want to point out that all of these are covalent bonds, also called molecular bonds, and they're all drawn different ways, but they all mean the same thing. So only one that I'll expect you to know how to do is this one, the electron dot diagram, and this one, this is called the structural formula. And we only draw a structural formula for covalent bonds. So these are the only 2 that I'll expect you to know how to draw. But if you see the others, now you know they exist. There you go. All right, so just to recap, we talked about ionic bonds in the previous video. I already told you ionic bonds are between nonmetals and metals. There's a transfer of electrons. There's positive and negative charges. There's ions involved. We will talk about all of this other stuff down here later. Don't be too worried about that. Covalent bonds are different. Covalent bonds are between nonmetals and nonmetals only. That's why they're called molecular formulas, because they're all molecules. They share, and there are no charges involved. And we will talk, like I said, about all this naming and fun stuff after Christmas. We're just going to focus on how the bonds form for now. Oops, that happens. Sorry, guys. So this one has 5, and then another one has 5. And what happens is they share these pairs of electrons, and we just replace those pairs with 3 lines. Don't be overwhelmed. I will help you. So what happens, that's how it forms a triple bond. So as long as you know that a triple bond is going to be 6 electrons or 3 pair, that's the big takeaway for this. Also, any covalent bonds that I have you draw, because this is tricky, this can be a tough skill, I will make sure that it's one that you know how to draw and that we've done it multiple times in class when I put it on the test. So don't be freaked out by that. This is that link. You do not have to go to it now, but I just want you to know that it's available. I'm going to also link it um, outside of this video, but this link is amazing because it allows you to rearrange the molecules, rearrange the electrons on the molecule so you can see how they're going to pair up. And then if you're stuck, you can just um, check your work and it'll show you how it's supposed to work. So this is a great, great tool. Definitely check this out when you're practicing at home. You've got hydrogen and chlorine not sharing the electron evenly. So once again, polar. Typically when you have two different elements, it's going to be polar. But I won't expect you to be able to look at an atom and understand if it's polar or nonpolar. The only one I'll expect you to understand is water, because we're going to talk a lot about water. But I will always tell you if they're polar or nonpolar. I just need you to know what that means. Here's kind of a choose your own destiny thing. If you want to watch this at a later point, this is a crash course chemistry. I think these are pretty entertaining, and it's about 10 minutes long, but he discusses polar and nonpolar. So if you just need someone to go back through it with you again and explain it to you more, this is a great video, but you do not have to watch it. Once again, more polar and nonpolar molecules. So you've got water up here that we talked about, very polar. It's bent. Methane, methane, if we were to look at it this way, it's CH4. So there's a hydrogen here. There's a hydrogen here. And this is kind of the 1D drawing of it. This is not two-dimensional, and a hydrogen here. This is nonpolar because all of these hydrogens are pulling the same amount, okay? But once again, I don't expect you to know that. Here's what's cool is when you understand polar and nonpolar, it describes properties. So like dissolves like, so things that are polar dissolve other chemicals or substances that are polar. Things that are nonpolar dissolve other things that are nonpolar. And oil and water, they don't mix because oil is nonpolar and water is polar. So that's why oil and water don't mix. So if you understand this, you can start to understand more properties. And that's why I'm kind of introducing this concept. All right, so more about polar and nonpolar. You need to know that water is bent. But we will talk about this a lot in class, and I'll make sure you have it in your brain before we get to the test. Another example of a nonpolar molecule, carbon dioxide, because these oxygens pull the same amount. It's like this tug of war, but each end is pulling the same amount. So that's why it's nonpolar. Like I said, this dashed line just represents those partial attractions between the partially positive hydrogen and the partially negative oxygen, and that's why water sticks, and that's why water has the boiling point that it does, and lots of things. There is a stronger attraction between the actual molecules. It's not a full-on bond, but there's stronger attraction right here because of those charges. Just another image showing you those attractions between polar and remember, covalent bonding is sharing electrons, and that polar nonpolar explains everything about its properties. So I believe this is your last slide, and this is it for your watch at home videos. So hopefully that wasn't too terrible or too long. Remember, you can come back to this video and the ionic bond video and watch it again to make sure you understand the concepts. And then, of course, I'm always available in class or activity. All right. Thanks so much, guys.